So let's start the session. Good morning, good afternoon, and good evening, everyone. A warm welcome to all of you. Thank you to each one of you for taking your time and joining us today for this session. I am Priya Chakravarti, and I'm delighted to be your coordinator for this session. We truly appreciate your time and interest. We have an exciting session right now, and the topic is monetize your GPUs, get to market faster, and how to build a secure multi-tenant AI cloud with aarna.ml GPU cloud management system. Let me introduce to our speaker for today, Shriram Rupanagunta, co-founder and CTO at aarna.ml, and Sandeep Sharma, principal architect at aarna.ml. Welcome, Shriram and Sandeep. Before we jump to the session, let me update you. You can watch the same session in our YouTube channel and also in our website very soon. So I will hand over it to Shriram to take it forward. Hi, Shriram.
Hello, everyone. Thank you. Thank you, Priya. So let's get started with the session. So let's move on to the next slide. Yeah, so let's start with the GPU as a service problem statement. So what exactly are we looking at? So the main intent is that people want to go beyond training. So until now, most of the people have been using GPUs for training, but now they need to acquire inference and fine-tuning customers. The second problem is how to create a secure multi-tenancy and SLAs. Because once you start signing up these enterprise customers, who are the high-paying enterprise customers, they will insist on the secure multi-tenancy and SLAs for the GPU as a service. And the third problem is how to offer on-demand and PaaS, the platform as a service. So essentially what you want to do is to charge more than just reserved bare metal or even the virtual machines. So that's really the problem statement for the GPU as a service providers. So let's move on to the next slide. Now, just to give an overview about the solution, the GPU cloud management software from Aarna, there are essentially two layers, right? So what you see in the middle of the diagram. So the bottom layer is called the infra manager. And the infra manager is responsible for creating the multi-tenancy with full isolation. So what we call as a hard isolation. And this is done at multiple levels, as we see in the subsequent slides. And the layer above that is a PaaS or a self-service layer for the platform features. And this is what enables the users to create instances and also do a job submission, model serving, and such features. So together, both these layers will enable the GPU providers, GPU as a service providers, to build a hyperscaler grade AI clouds. So essentially, transitioning from a static GPU rentals to a fully dynamic, multi-tenant, and on-demand infrastructure. So that's essentially what the software enables you to do. And the picture that you see at the bottom is the entire GPU grid, right? All the way from edges to the centralized data center. So the uniqueness about the GPU CMS, Aarna's GPU CMS, is that it can scale all the way from edge to the centralized data center seamlessly. So you can use it only on the edges, only in the centralized data center, or across both the layers. So let's go on to the next slide. So in terms of the details of the cloud management software, so as I mentioned in the previous slide, there are two layers, the infra management and the platform management. So the diagram on the left-hand side shows both these layers. So right at the bottom of the diagram is where you see all the hardware. It could be the CPUs, the GPUs, the NVLink in case of NVIDIA hardware, the H100, 200 servers, and also includes the networking, the Spectrum X or Cisco or any other vendor switches, the InfiniBand, which is it uses the UFM to provide the isolation. And then the storage, which could be from any of the vendors, DDN, VAST, Veka, or any other vendors, and also the gateways for providing the VPCs and external connectivity. So that's the bottom hardware layer. And above that is the hardware provisioning. So the provisioning can be either the vendor's provisioning software, or the CMS has its own way of provisioning these servers using Redfish APIs. And the layer above that is the infra manager, which essentially provides an ability for administrators to create all these offers, either bare metal virtual machines or CAS, which is essentially Kubernetes as a service. So the administrators can onboard all the resources, create all these offers, either as a bare metal offers or a virtual machines, Kubernetes, and then set the pricing for each one of them, and also have an ability to do the observability. So they can look at all their infrastructure, the inventory, any faults, alerts, all of them is available. And the layer above that is the platform layer, which is the user facing. So that's the layer that enables the GPU as a service provider's customers, their customers, to create the instances, do the model serving, do the job submissions, and then there are a lot of other features, such as running Slurm, Run AI, and then registering their spare capacity with NVIDIA's NVCF, and so on. So all these features are available as part of the platform management. And in addition to that, there are a couple of other points that I wanted to just highlight. One is the approach that we have is that the multi-tenancy is provided as a hard multi-tenancy. So what that means is that each of the tenants of these GPU service providers have exclusive access to all this hardware, be it CPU, GPU, networking, and all the other layers, which we'll mention in the subsequent slide. So all of them are provided as a in a sort of a hard multi-tenancy with high quality security conscious customers, right? So obviously people don't want to share these resources across the other tenants. They don't want to have any noisy neighbors. So all of them are addressed by having this approach of a hard multi-tenancy. There are a couple of other features that I wanted to highlight, which is, so one is about the billing. So essentially, if the GPU providers already have their own billing software, we can interface with that by providing all the necessary metrics for the billing. Alternatively, we have integrated with one of our partners' billing software. It's called Monetize 360. So with that, it's a fully integrated single pane of glass through which the administrators and the users can see their billing. The administrators can generate the invoices. The users can see their own billing, and so on. And lastly, there is a user management and RBAC functionality where the tenants of the administrators of the GPU as a service providers can have their own identity provider. For example, each tenant can have their own ID providers. One can be a Google, they can use the Microsoft identity provider, or they can import the users. So the multiple ways of doing the user management. And then there is an RBAC where each of the users, each of the persona gets certain privileges and certain access permissions. And the last point I wanted to mention is there is also an ability to use up your spare capacity. So let's say the GPU as a service provider has some spare capacity after selling to all their tenants. And that spare capacity can be elastic, it can be dynamic. because as more users sign up, you will sell more of these resources, and the spare capacity can be increasing or decreasing over time. So what they can do to monetize that is to register that with the marketplaces. So what we have done is integrated with one of such marketplaces with from NVIDIA called NVCF, NVIDIA Cloud Function, using which the spare capacity can be registered with NVCF, and NVIDIA will help monetize that. So essentially, they will use this spare capacity to sell to their users, and they in turn pay the GPU as a service providers for the usage of the resources. So the the key here is to ensure that whatever capacity that is spare capacity that is given to these marketplaces is again fully isolated, because you don't want that capacity to be sharing with other tenants who have already paid for it. So that's another key feature that we provide, where the spare capacity which is sold is again fully isolated, and it can be dynamic. So we can add more resources into it, or we can take them out as required. Yeah, so let's go on to the next slide. So this talks about the user personas. The CMS provides 3 levels of users. At the top, what you have is the administrators, a super admin, or it can also be called NCP admin in case of the GPU as a service provider being an NCP, the NVIDIA Cloud Partner. Or it can be just a GPU as a service provider, in which case it's a super admin. So this is the persona that's responsible for onboarding all the resources, creating the tenants, creating the billing accounts, looking at all the observability. So essentially, this is the owner of all the resources, all the hardware resources, right? So, and then there is a tenant that is created by the super admin. And the tenant itself has 2 different personas. There is a tenant admin persona, who is the user, who is typically an IT administrator of the tenant, of that enterprise, who are responsible for setting up, the quotas for the tenant, creating the billing account with the administrator, and so on. And then they in turn invite their users, and these users are the end users of the tenant. Typically, the developers, the data scientists, whoever actually requires these GPU resources, right? So they are the ones who will eventually consume all these resources. They will either allocate them as just as a bare metal or virtual machines or clusters, or they could use higher level services that we talked about earlier, which is to submit the jobs, to create the inference models. All of them are done by these enterprise users, right? So these are the 3 personas. In the demo, you will see how you will actually create each of these personas, how you'll invite them, and then so on. Yeah, so I briefly talked about the hard isolation earlier in the previous slides. So essentially, we look at them from 7 pillars, right? So 7 elements of this isolation, because it's not enough if you just isolate at any one of these layers, right? For example, you could just do only network isolation, right? But that's not sufficient, because the tenants will be using all the other resources, right? They will also be using InfiniBand, they will be using NVLinks, they will be using a common storage across all of the tenants. They will, of course, have an external connectivity through the WAN gateway. And of course, there'll be compute and the GPUs. So it's not enough if you just isolate at 1 or 2 levels. You have to isolate at all levels in order to be effective, right? So in our case, we look at it as a hard requirement to isolate at all of these levels. So when you create a tenant, and a tenant allocates any resource, as a bare metal virtual machine, or even a cluster, or they do a job submission, the CMS ensures that their resources are isolated at all of these levels. Yeah, can go on to the next slide. Now, so let's also talk about some of the benefits, right? So why Arna? So there are primarily, two kinds of benefits. One is a technical benefit, the other is a business benefit, right? So in terms of the technical benefits, I've already talked about the first one, which is a comprehensive, fully isolated multi-tenancy for secure access. So that's a clear benefit that very few solutions out there provide it. In fact, probably no one else provides it. Um, the second benefit is on-demand infra and the platform. So you can actually start with the customers um, with only the infra, and then provide the platform services for higher price, right? So this actually enables the GPU providers to start with something with only infra, and then add the platform using the same software without any additional software. And the third one is the observability. So we have a very advanced observability at various levels. The admin has the observability of the entire infrastructure. They can also look at the faults. There are some ways to um, reduce your OpEx with fault management, with some automated uh, actions which can be set up. So these are some of the technical benefits. In terms of the business benefits, the first one is the integration with the marketplaces like NVCF, right? So this essentially enables you to monetize all your spare capacity, right? So obviously for a GPU as a service provider, um, monetization is the number one business requirement, right? So if they are not able to use up all the GPU resources for all their customers, they are essentially going to be losing money on these GPUs, right? So what we enable for them is to register their spare capacity and do that in a very elastic way, where they can add into it, remove from it in a dynamic way. So this enables them to monetize whatever is capacity that is sitting idle, essentially. The second benefit is GUI customization and integration services for differentiation, right? So we not only provide the base product, we also enable certain additional features that they require by providing the integration services so that they can differentiate based on their strengths compared to their competitors. And lastly, our pricing models are quite flexible. So, and of course, if you talk to us, we'll let you know, what kind of models that we have for pricing the software. And lastly, we are an NVIDIA funded company. So that's another benefit that you're going to get, but both for technical as well as the business benefits. So now let's move on to the demo. So before I turn it over to my colleague Sandeep, let me give a quick introduction to the demo and what we're going to see today. So this is the demo configuration that we'll show in the demo. So it's a tier three configuration, network configuration. So what you see as the core, spine, and leaf are the network switches, the Ethernet switches, which are essentially Spectrum X switches. And what you see at the bottom, the leaf nodes, are the servers, the HGX. It could be MGX or DGX, any of the servers. And then the storage nodes. So we also have some of the storage. So in this demo, we are going to show with the vanilla NFS server, but we can also support any of the storage vendors like DDN, VAST, Weka, or others in the future. And then what you see on the left-hand side is the out-of-band network. And then our software, which is the aarna.ml software in the blue box, also runs on one of the nodes in the management nodes on this network, right? It doesn't run on these the actual GPU nodes. It runs on one of the management nodes. And then we create all these personas that we talked about, the NCP admin or a super admin, and then the tenants, tenant one, tenant two, and so on. And that's what you're going to see in the demo. So it's a sample 3-tier switch configuration. And this is the demo storyline which Sandeep is going to walk you through. So as we talked about the multiple personas earlier, so we're going to show uh, with all of these personas. So first we'll start with the admin persona, the super admin persona, which is responsible for provisioning the infra, onboarding the infra first, either through discovery or through manual onboarding. So in the demo, we'll show it with a automated discovery. And then there is a notion of a topology validation, which is a very important feature, a day zero feature, where the GPU providers want to make sure that whatever topology that is that's connected is in line with what they actually intend to have. So they can do all of this validation in a digital twin and then validate that on the real hardware. So that we're going to see that feature. And then, of course, the underlay configuration, the observability, monitoring, and self-correction. So we'll see some of those features in the demo. The benefit is the zero-touch automation and OpEx reduction. So that's essentially the benefit of all of this. And then the second step on this demo, which essentially enables the tenants to create the VPCs, the virtual private clouds for their own networks, the isolation, allocating the storage, the cluster creation, the billing. So we'll see some of these features between the tenant admin and the tenant users. Um, and under the hood, essentially what we'll do with all of this is multi-tenancy with hard isolation, which we just talked about. And then the last uh, persona is the tenant user persona, right? So that's the persona that eventually consumes all this infrastructure. So you can consume it in two different ways. One is in an explicit allocation. So they can go in and allocate a bare metal server or a virtual machine, use it as long as they need it, and then free it up when they're done with it. Similarly, they can allocate a cluster, a Kubernetes cluster, do their own jobs on that. And again, with each of them, they can allocate based on their looking at their pricing information. The prices are set by the administrator, and when the user looks at these catalog, they can see all these offers, either bare metal, virtual machines, clusters, and they can also see the pricing. And based on that, they can allocate them as needed. Right. So that's one feature that you're going to see. And then the last feature that you're going to see is the higher level platform features, where the users can submit jobs or they can create serverless endpoints. So essentially for model inferencing, right? So in that case, they won't explicitly allocate the hardware. Instead, they will create a model inferencing endpoint, and then they can offer it to their customers, right? So in this case, it'll be really the tenants' customers, right? So as you can see, there are multiple levels here, right? So the GPU as a service provider will offer it to their tenants, and the tenants in turn can offer it to their users or their customers with all these models, right? So that's the demo that you're going to see today. Without much ado, let me turn it over to my colleague Sandeep, and he will walk you through the demo. Yeah, over to you, Sandeep.
Thanks, Sriram. So let me first share my screen. Okay. So I'm going to walk you guys through the demo. So it is pretty much the flow, the functionality features that Sriram described in his slides. So we are going to see the end-to-end flow, right from the infrastructure discovery, provisioning, to the point where the tenant admin deploys a shared inferencing endpoint and invites his users to access the shared inferencing endpoint. So to begin with, I will log in to the platform as the NCP admin. So NCP admin's responsibility is to manage the infrastructure, onboard the tenants, handle the billing and pricing. So the first step that the NCP admin performs on day zero is the discovery of the infrastructure. So this is the form that he has to fill for discovering the infrastructure. So in this demonstrations, we are essentially discovering two network topologies. One is the compute network topology, which consists of the Spectrum X switch fabric and compute nodes, and the storage topology, which has a storage server and the Spectrum X switches again. So we do support storage from different vendors, VAST, Weka, DDN. In this demonstration, it is a plain NFS server in this topology. And the third piece of the hardware that we are going to add is the external gateway. We are going to use the F5 big IP as the external gateway. So this essentially provides the external access to the workloads that are deployed on the infrastructure that the users provision. So that we will see towards the end of this demo. So what we need to provide is essentially the MAC addresses of the core switches. And then in the backend, the discovery algorithm kicks in and it discovers the whole topology. And that we will see once the discovery finishes how the topology looks. So this is what I was talking about. We are now onboarding the storage. So now we are going to provide the external gateway information. So we are onboarding the gateway node. So we will provide its management interface and the related details. Also, we provide the information about the border leaf. Border leaf is the gateway to the topology where the routing happens from the external network to the internal switch fabric. So this is the endpoint of the F5. The networks that are present on the F5. So the two networks, basically the internal facing and the external facing networks. So these are the external IPs. So we are providing a bunch of external IPs. So these will be assigned to the resources, the VM or the metals that are allocated. And this using these IPs, the user will basically access the workloads that are deployed on the VMs, metals, or Kubernetes cluster that he creates. So this is all the information that is required to import, to discover the infrastructure. So in this demo, it is the Ethernet switch fabric. We also support InfiniBand. In that case, on this form, we have to provide the information about the UFM, and the discovery is performed via the UFM. So this is how the topology looks. So we have the switches, the spines, leaves, and the compute nodes, and the storage as well. So this is the infrastructure that is discovered. We discover all the connection details, management, compute, storage nodes. So everything is unallocated at present. So it is just discovered. So it does not even have the underlay network yet. So you can, so this whole topology is clickable. So if you see, we can click on the nodes. So that highlights the connection of the nodes to the related switches. So which makes it more, the overall UE experience very intuitive. So the connection information. You can also rearrange the nodes in the topology and save the view. So now we onboard for the telemetry, we are going to onboard the NVIDIA NetQ platform. So once this platform is onboarded, so this basically provides the observability of the switches. So once it is onboarded, we will start getting the telemetry data of the switches as well as alerts from the switches. And the NetQ is also used for validating the topology. So this ensures that the infrastructure that is discovered is same as the topology, the topology intent that was specified. So for validation, we are uploading the dot file of the topology that we discovered. So NetQ is performing the validation, and we see that the validation result is successful, which means the discovery went through fine. So with all the infrastructure discovered, now we can create the network underlay. So this will create the BGP underlay on the switch fabric, and that becomes the base for network isolation. So all the hard isolation that Sriram talked about. So in this scenario, only the VXLAN and VRF uh, networking constructs for isolation are applicable. If it was InfiniBand, we would create the P keys for the isolation. So once the underlay is done, we can see the network details that were. So that basically shows the management interfaces of all the loopback interfaces of the BGP configuration. So this is the NetQ, the telemetry agent that was onboarded. And I talked about the events that the NetQ generates. So it is configurable. So using this screen, we can subscribe for the events that we want to get. And we have also implemented the auto correction. So the events that we are subscribing to, and on the day and when we get these events, so the system automatically detects the fault and it tries to autocorrect the fault. For example, the link down, BGP session, config diff, and NetQ agent status. So these are the events. So if we get an event for link down, so we figure out the switch that on the switch on which the link down has actually happened, and we fix that. And same thing goes to the config diff. If the config drifts from what we had applied during the underlay, so then this event gets generated. And in reaction to that, the system, uh, basically the network controller in the backend, it goes and it autocorrects that by applying the last known good configuration. So this is the interface where we subscribe for the events, and this is the product catalog. This is the hardware that is discovered. So the discovery flow, once it discovers the server, it basically using Redfish, it logs in to the server and it gets all the hardware detail of the server, which provides the number of GPU types, NIC types, and the other PCI devices. And based on that, we present the flavors here. And so once we get flavors on this catalog, we can set prices to these flavors. So in this demonstration, there is only one kind of server. Hence, we see only one card on this interface. So we set the price to that. So this is now we are setting the price for the storage. So this is the storage that we had discovered during the discovery flow. So now we are going to add the tenant. So during the tenant addition process, we also configure the billing related information. So once the tenant is added, we create an invite a user, and we set the role as the tenant admin. So this invitation in the backend sends an email to the user, and then by accessing his email, he has to follow the subscription process, which we will see in the demo. So this is the tenant added. So now this is the billing interface, the M360. So this is how the interface looks. So at this point, the tenant is added and a contract for the tenant is created. And the contract basically includes the product types and the pricing. So that is the pricing that we were setting on the storage and compute. So at this point in this contract, there are only two kind of products. So now that was the overall flow for the infrastructure setup and the tenant onboarding. So now switching to the tenant persona. So the tenant persona is now accessing his email, and he is going to register himself to the platform. So we support identity federation. So it depending on the identity provider of the tenant, whether it is LDAP or login with Google or Azure. So that is, I mean, that can be configured, and different tenants can have different identity providers based on what they already have, and that we call as the identity federation. And we also support multi-factor authentication. So now the tenant user has registered himself and he logs in. So now we are going to perform the uh, infrastructure related operation, infrastructure allocation related operations. So the first step is creating the networks. So we are going to create two networks, compute and converged. So these are the isolated networks for this tenant, and any compute that he creates will be basically allocated in this network. And these networks in the backend, they translate to VRFs and VXLANs. So converged network, as the name says, the converged network is provides the external connectivity as well as the in-band connectivity. So in-band is used for all the compute and other resource, compute and switch management, observability, and the all the post provisioning processes that we perform on the compute node. So basically, the flow, the access from the CMS to these resources is over the in-band network. So now we have the two networks created. So this is the security group. So we are going to create a default security group. So according to this, the configuration on the F5 will happen. So this will be applicable on the external connectivity flow. So now we are going to allocate resources. So we are going to allocate the bare metal first. So this is the flavor of the metal. We select the networks that we want to attach this network to. The number of compute nodes, and we enable the external access. So now the compute nodes are getting allocated. So while they get allocated, we go to the storage. So this is the parallel file system allocation flow. So in the backend, in this demo, it is an NFS server. So you select the compute. Since it is a demo, so only 1 GB, we are specifying only 1 GB. Okay, so storage is allocated and the storage is mounted. So basically NFS mount is created and it is mounted on the compute node that we had selected. And that is over the storage network that is created in the backend. So clicking on the compute node shows the observability. So this is the storage of the node. So these are the networks, the compute and the converge network. We see it got IPs in that network. So this shows the CPU observability because the node that is present, the compute node that is present in this topology has only CPUs. If it had GPUs, then we would show a tab here which shows the GPU observability. Let's skip this. So that was about the compute node allocation. So now I'm going to show the VM allocation flow. So when we discover the compute nodes, we implicitly create certain flavors, that certain VM flavors that can be accommodated on the compute node that is that is discovered, that is part of the topology. So in this demo, we see that there is this flavor which got created automatically. If this was a server with 8 GPUs, we would have seen 3, 4 flavors here with 1x, 2x, 4x, and 8x GPUs. So these flavors are created automatically by the platform, as I said. And there is also a flow for the admin, NCP, for the NCP admin to create custom flavors. So, I mean, they can edit them and create custom flavors as per the requirement of the tenant who is getting onboarded. So in order to access the VM data, provide the SSH key. And the VM got created. So next, the third type of resource or instance is the Kubernetes cluster. So we had allocated 3 compute nodes. Now we can create a cluster on those nodes. So we will select upstream and the version, upstream distribution of the Kubernetes, the version. Also install the NVIDIA GPU tools and select the compute nodes on which we want to create the cluster. So these will become the worker nodes of the cluster. Now we see that the cluster creation is in progress. So this is how the cluster looks, and we can scale these clusters manually. We can add and remove nodes. The auto scaling is a feature which will be present in the next demo that we will do. And we see the workloads tab. So going on this tab, so through this workloads tab, we can deploy the workloads on the cluster. So this was about the the tenant and tenant user flow, where he can create and allocate different kind of resources. So now we will see the end use of these resources, which is essentially deploying the AI/ML workloads and accessing them. So in this demo, in this flow, the scenario that we will show is that the admin is going to deploy certain models, and then he will host those models for shared inferencing. And then we will see the users log in, they allocate an API key and access these shared inferencing endpoints. So for that, we go to the platforms tab. So this is the flow for deploying an endpoint. So we essentially, I mean, we have to provide two inputs here: the model that we want to deploy and the flavor of the VM on which we want to deploy this model. We select the model and we select the flavor. So clicking on deploy, so this flow in the backend, so it creates the VM based on the flavor that is selected, as well as deploys the model and exposes the endpoint. So this is the flow that the admin follows in order to create a catalog of the endpoints, a catalog of the models which are hosted. And once he onboards or deploys multiple models, so this is how the catalog looks. So we see there are different models that are deployed and pricing is set for these models. So this pricing is for the end users who are going to access these inferencing endpoints. And billing here is token based. So we meter the tokens based on the both the input and the output tokens, and they are accounted for every user, and that becomes the metric for billing. So the first thing that the user has to do is allocate a key. So once the API key is created, using this API key, he can access any of these models, and he will be charged based on the pricing and the tokens he consumes. So we copy the API URL, and we see the payload has a model name. Now we can take this endpoint and integrate with the application that the user is building, the agent that he is building, chatbot, whichever way he wants to use. In this demo, we will show a simple curl command to showcase that the endpoint is accessible. Yeah, so we enter a question on the prompt and get the response. So this is how the shared inferencing endpoint can be used by the end users. And we show the tokens that are consumed with that one API call. So this is the end use, but there is also a provision of the playground on this interface. So this is for the complete cycle where the end user fine tunes a model, deploys it, and they want to test it before they actually integrate the API endpoint with their application. So the playground lets you access the the model. So in this case, we are accessing the Mistral model and we asked it to write a simple code. We Yeah, so we see that it works. We get the response, and on this playground we can use any of the deployed models. So we can change the model from here itself. So this is the platform, the CMS platform feature. So where we saw the use of the infrastructure that was allocated by the admin. So we showed the example of model inferencing. So similar flows are present for the model fine tuning. So now with all that, in order to complete the flow now, so now we will see the billing part, the invoice generation. So we had taken all the billing information while onboarding the admin. So now this is the part where the NCP generates an invoice for the admin based on the resource usage of the tenant. So we see the billing information, and we will finally generate the invoice, which will be sent to the admin by the NCP. So this completes the flow. So I went through the whole flow, right, starting right from the infrastructure discovery to allocating that infrastructure, allocation of that infrastructure by the NCP customers, and running the workloads on the allocated infrastructure. So, so this concludes my demo. So back to Sriram.
Yeah. Thanks, Sandeep, for this wonderful session and guide. Can we go to the last slide, please? Yeah. So before we end this session, if you have any queries or any conversation that you would like to take forward with you, please do write to us at info@aarna.ml. We truly appreciate the time you take to attend our session where we intend to share only knowledge. See you all soon. Good day and good night. Bye-bye. Thank you once again, Shriram and Sandeep. Thank you. Bye-bye. And thank you, everyone.